Example 5. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents this path. So if we take a look at the picture, the green line is the shore. So I'm assuming maybe there's like a beach back here, and then these guys are out over the ocean or over the water. Now, the rescue guy is sitting right here at 14.4, and he's got to get to the shore. And the shortest distance between any 2 points is a straight line. And the way we ensure that we have a straight line is that we go perpendicular and we hit it at a 90-degree angle. If he were to fly maybe like over this way, if you take a look at that blue line versus just that red line, this is going to be longer because he's flying at an angle. So he's got to go 90 degrees. Now, they want an equation that represents his path, which means we need the equation of the red line. Okay, so the first thing I'm looking at is I'm looking at whether or not I can maybe get the slope of this red line, because I want it to be perpendicular to this. So let's try a couple things here. First of all, the slope of my shoreline, which I'm going to do in green here, I could find any 2 points, and I'm going to say this one hits exactly, this one hits exactly. If I take a look at it from the left to the right, it's kind of falling, which is negative. So I know my rise over run better be negative. So I'm going to rise, which means I'm actually going to drop. 1, 2. And then I'm going to run. 1, 2, 3. So I know the slope of my shoreline is negative 2/3. Now let's find the slope of our helicopter. Any 2 points, it looks to me, well, we know this one, 14.4, but it looks like we also might be able to place maybe like this one right here. So I'm going to drop negative 1, 2, 3, and I'm going to run backwards, negative 1, 2. So that's going to be negative 3 over negative 2, which is really positive 3/2. So are those lines, in fact, perpendicular? So if they are, they have to be opposite. So one has to be positive, one has to be negative. Yes, yes. And then 2/3 has to flip upside down to become 3/2. Yes, yes. So those are perpendicular lines. Now, I want the equation of the red line, so the slope we're going to use is we're going to use this one. Now, I wasn't given a y-intercept. That would be down here somewhere. I can't find it. So we were also given this point 14, 4. So I'm going to do y minus y1. So x, y, and I'm using 14, 4. So I'm going to substitute in 4. Equals my slope of 3/2 times x minus x1, which is 14. And then I'm going to look at that, and I'm going to read, does it say, it just says write an equation of the path that represents that line. So ultimately, I'd probably just leave it like this. And that's the equation of the path of the helicopter. Number 6, in example 5, so the one we just did, a boat is traveling parallel to the shoreline. So now we have a boat somewhere, and passes through the point 9, 3. Okay, so I'm going to find that. Over 9, up 1, 2, 3. So here's my boat, and he's traveling parallel to the shoreline. Well, parallel means same slope, kind of the same line. Write an equation that represents the path of the boat. So just to recap, my shoreline, we knew that we had this point right here, and we knew that we had this point right here. So we went down 2 over 1, 2, 3. So our slope was negative 2/3. Now my boat is traveling parallel to that. Well, parallel means we have to do the same thing. So negative 2 down 2 over 1, 2, 3. I could do it again. Down 2 over 1, 2, 3, which is going to get me the line of my boat. So my boat is traveling parallel. So my purple line is never going to touch my green line. So my boat also has a slope of -2/3. Now, they want the equation that represents the path of the boat. So same idea. We're going to use this slope, and we know that the boat is going through the point 9,3, so we're going to use that point. Y minus xy 3 equals my slope, -2/3, times x minus 9. And then I'm going to look, there's nothing really in there to clean up. It doesn't say what form we need this in, so I'm just going to leave it in point slope form. And that's the equation of the path of the boat.